Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and so far we have looked at how to call methods of an object from C++ using the JNI, and in the previous lecture we looked at the instance methods, and we said that it's very similar to getting the fields. So we have to get the J class that has the meta information of the object that we want invoke or call the method of this object. And then we get a J method ID. This is a method identifier that has all the meta information of the method. This is actually a pointer to the method object on the Java heap, right? So we say get method ID and then pass the reference of the J class, the name of the method, and the signature of the method. And this method signature, basically in parentheses we have the signature of the parameters, and after that we have the signature of the return type. And again, if it's a primitive return type, the way we called it for the instance method was saying that call whatever the type of primitive of the return type is, and then method, call double method, call int method, call float method, and we pass a reference to the J object and then the J method ID, and then we have a var args parameter for all the parameters that this method takes. If the method return type is an object like a string or something like that, then we have to use the call object method. This means call the method that returns an object, right? So here the primitive and the object refer to the return type, and then we pass a reference of the J object, we pass a reference to which method to call, and then also the parameters of that method. Now for the static methods, it's very similar. Again, we need the J class meta information, the pointer of a J class that gives us the information about the object. So we can use find class and then give the class path description of the object. And then here we have to get the static method ID. This is very similar to the fields. For fields we had get static field ID. Here we get static method ID. So the keyword static gets added because we want to get the identifier, a method identifier of the static method. And then J class, the name and the signature of the method, which basically includes the signature of the parameters that it takes and the signature of the return type. And then we ask the JVM to invoke the method by using one of these call methods. Call a static double method. So if the return type is primitive, we use call a static, whatever the primitive type is, double, int, float, etc., boolean. Instead of J object, we pass a reference of type J class because this is going to be a static class, and static methods are associated with a J class, a class itself, not an instance of a class. And if the return type is object, we use call a static object method, and J class, J method ID, and all the arguments, the value of the parameters or the arguments that the method takes. And this one returns an object, a J object, and we can typecast it to whatever the return type is. So if the method returns a string, I can typecast it from J object to J string. All right. So let's head to Eclipse and try to look at how we can call a static method from C++. So I'm going to create a new package. Let's call this test 13, and I'm going to create a class called person. Again, the same routine, and this person is going to have a basically static method, public static void, or maybe let's say void print info. All right, and this takes a person and then basically returns. So let's add some parameters. So a string name and then int age, and then we add a constructor public basically public person, and then a string name and int age, and we just use this dot name is name, and then this dot age is age. Okay. Now let's say we want to so we have a static method for printing the info. So we can have a toString, for example. So source override implement method, or maybe let's just generate a toString. Source, generate toString, and then name and age, and then where do we put it? After the constructor. Okay, and here we just call the toString. So person, so basically person dot toString. All right, and then we can also have a static method, public static void set info. So we pass in a person and a string name, and then an integer as age, and then here we say that person dot name is name and person dot age is age. And note that even if these are private variables, we can still access them here. That's because we are still within the scope of this object. Within these two curly brackets, we can always access private fields. Okay, so this is the person object. So let's create another class to test this. Test call a static method, and okay, here let's have a main method. So in test1, I'm going to have basically two tests to test each of them, and then test1 public static void test1, and then public static void test2. And what I'm going to do, I'm going to create a native method, public static native, basically yeah, we don't really need, so these we want to call these, so yeah, so there's no need to basically call them. But then what I can, so yeah, so basically what I can do here, create a native method, public static native, basically let's just say call print info, call print info. All right, and then what we are going to do, public static native, let's say this is void, and then here I'm going to create a person is new person, and then let's say Bob, and then age 21, and then we're going to call person info on this object, right? Person person all right, so what we're going to do, we're going to send this object person to the C++, and in C++ we're going to call this static method in the person class, and then pass the person that we are sending to C++, and this just calls the toString, and Java prints it to the console. All right, so this is a little bit convoluted example, but that's how it's done. So yeah, so this is the example, and again you already know the routine. We go to the C++ perspective, and then click on the Java file that has the native method, and run the Java H or Java C-H to create the header file. So this is going to create the test 13. All right, this is here, and then let's create a new source file .cpp file and call it basically call static methods.cpp. And the very first thing that we do, as always, we include that header file .header, and then test 13. And basically the reason we do this, because we need to also make sure that the JNI.h is included. All right, and then we copy and paste this method, this function prototype, this declaration, and then add the body. So J class refers to the calling class because it's a static method. It is a J class reference, and J object is the person object that we are passing. And again, the goal, what is the goal? The goal is to basically call the print info method that takes the person in the person class, right? So we want to, step one, get the J class, and which J class for this person class, because this method is inside this person class, right? So what we need to do is say J class, person class is environment get. So we can either use find class, or because we already have an instance of this, we can use the get object class, because we already have an instance of this object, and then pass the person. All right, I personally prefer to always use the find class, but here then because sometimes or most of the time we don't have a J object reference, but here we do, so we can either use find class or get object class. And we have to specify the class path, which means the package. This is test 13, and then the object, which is the person. All right. And step 2, because we are calling a method, we want to get the method identifier, and this is a static method, so have this in mind. So J method ID, let's say print info ID is again environment or JVM. Actually, let's change this to JVM because it's more clear what we are doing. We are clearly asking JVM. So JVM give us the basically get a static method ID. All right, and then we have to pass a J class reference, person class. The name of the method is basically print info, and the signature of the method. What is the signature of the method? It takes an object, so we have to use parentheses here, these round brackets, and then the return type is void. This print info doesn't return anything, so it's void. We have to use V. And then here it takes a instance of an object, right? So L semicolon, and what is the signature of this parameter, which is person? It's the package name slash class, right? So test 13 slash person, and it should be between the L and semicolon. And again, if you don't remember how to write this method signature, then you can just quickly go to Java perspective, go to the person class, click on this person info, the method that you want, go to the bytecode view, and let's zoom here. So this is the name of the method, and this is the signature. So it takes a parameter of type person. So it's an object, so it should be between L and semicolon. And then the class path or the signature of this parameter is test 13 package slash the class name, right? This is the class path description. And again, going back to the C++, so we get the method ID, and then what is the next step? So the next step is to just ask JVM to call the method. All right. So when we get this method ID, we don't need to basically specify the actual parameters, the values. We just specify the meta information about the parameters. What is the parameter type? These are the meta information, not the actual values. And what is the return type? All right. And JVM tries to look into the meta space, and then match a method that find a method that matches this description, the name, and the parameter type. The reason we need this part, the method signature, is because of the fact that Java allows method overloading. So we can have the same name for two different methods that have different parameters, right? That's why we need, not only we need the name of the method, we also need to specify the signature of the parameters. So here we just say, okay, JVM, just call a static, and this is a void method, right? So we treat it as a primitive type, void, call a static void method, right? Void is like a primitive type because it doesn't return anything, it doesn't return an object. So what is the J class? Again, because this is a static, we send or we pass in a J class reference, not a J object. What is the basically class here? Person class. All right. And then method ID, which method? Print info ID. Now obviously something is missing from here. We have this vararg that specifies the actual values for the parameters of this method. And what is the parameter of this method? A person object. So we have to pass a J object reference, which is this person, right? So we pass this person. All right, this should work fine. And again, this goes into the Java to this object and calls this method, and this method uses the Java IO to print something to this to the console, right? Actually, we should basically do a sysout on this. Sysout person dot toString. Actually, we don't need the toString because the print line automatically calls this the toString on the objects. So let's compile this. It compiles fine. Let's copy and paste the dynamic library that we just generated to, and then basically override the previous one. I'm going to say yes, and it's going to override it. And then we go here and run our test one, and it throws an unsatisfied link error because we need to load the dynamic library into the memory. When we run this class, system.load library, and then the name of the library native C. So let's run one more time, and it works fine. Bob age 21. So what did we do? We created this object in Java, send it to C++, and in C++ we basically invoked or called this static method inside this person class, and we pass in a person object to it, and it came back to Java, used this print stream, which is a Java IO stream, and then wrote something to the console. All right. Okay, so this is the static method, and the other one is we can also test this set info. So what I'm going to do here, I'm going to create a native method here, public static native void set info. Actually, let's return a person. Set basically call set info, and then a string name, and then int age. Maybe let's because this is a static, let's also send the reference of the person. Okay, so what I'm going to do here in test2, I'm just going to create the person again, but then I'm going to call this set info method, and send the person along with the new name, James C++, and age 31 to C++, and C++ is going to replace the name and age of this object with these new values. Okay, so what I need to update the header file. So I select my Java code, Java object, run the Java Edge tool, and it creates the prototype of this new native method. I go back to my C++, copy and paste, and then JVM. J class is the reference to the calling class. J object is the person. J string is the name, and J int is the age. And these are basically the new values. And again, we need this reference to the person class because we're going to call a static method inside this person class. And now we need a J method ID. J method ID. Basically set info ID is JVM get static, basically method ID, reference to the J class, person class, the name is set info, and the signature is what? So the return type is void, right? So the return type is void. The parameter type is we have two objects, one person object, one string object, and one primitive. So obviously let's write it, but it's always easier to go to the Java bytecode view and copy and paste it. But for now, I'm just going to write it. So let's zoom in here. So we have two objects. So for each object, we write a L semicolon. The last one is integer I. So inside each object here, we have to specify the signature of the object, the class path. So the person object is inside the test13 package, and the name of the class is person. The string is in Java /lang/string. All right. So the signature of this method is L test13 person semicolon. This is one parameter, the first parameter. The second parameter is the signature of a string, and the last one is integer, and the return type of the method is void. All right. So this is how we write the basically the signature of the method. And of course we can go to the to the Java perspective bytecode view, and then click on this method set info, and then let's zoom on the method, and this is basically the same thing, right? So L test 13% semicolon, this is one parameter. L java /lang/ string semicolon is another parameter, and then integer, and the return type is void. All right. So each object should be between a L and semicolon, and then you have to describe the full class path of that object. So now we have this J method ID. The last thing is to ask JVM to call it. JVM, please call the static method, and the return type is void. So call static void method, and then we pass the J class, J method ID, and obviously the parameters. It's a vararg parameter list. So the first one is person, the second one is name, which is a J string, the last one is age, which is a J int. All right, and this should work fine. So let's go back to the C++ perspective, compile. We have an error. So unexpected type name J, sorry, so this J int should be age basically, right? This is the name of the parameter. So compile again, works fine. Let's copy and paste the new dynamic library to the Java project, and then go back, and now we're running test2. And after the person name is modified, I'm going to do a sysout on the person. So before sending it to C++, let's do a sysout on the person. And maybe let's write something like before basically plus this, and then after plus this. All right, let's run test2. And before was name Bob, age 21. After that we went to C++ and came back, and the name is James C++, and age is 31. So we successfully sent an object to the C++, allowing the parameters that we want to set, and then we call the static method in the object to actually set the values. All right. So this is all that there is about the static methods. I mean, obviously you can also call the static methods in basically the Java JDK packages. For example, let's have a public static native void print memory. All right. And then let's put this in a test3, public static void test3, and let's run this test3. So basically JVM has in the JDK we have this runtime class, and it's a singleton, so we can get an instance of the runtime, and it has a method called basically free memory, for example. Okay. So it has available processors, and then free memory, and max memory, etc. So let's say free memory. Okay. So this returns the amount of free memory that we have. And now what we want to do, we want to call this get runtime method. All right. And this returns an object of runtime. And then we want to call the free memory on this object, right? So if I have the runtime, and then so I have to call this get runtime method, which is a static method first on this class, and then after that this returns an instance of an object runtime, so it returns a J object, and then I have to call the basically free memory on this, and this returns a long, so long value. And we can actually, this is a primitive long, I believe. Yes. And this basically we can do a sysout on this value. And this value is in bytes, so divide by 124 to get the kilobyte, divide by another 124 to get the megabytes. So let's run this. 242 megabytes. This is the free memory that the JVM right now has. Okay, so this is like a chaining the method. So we have to have one method call to get this runtime object, the instance, a J object, and then call this free memory method on that. And incidentally, this free memory is actually a native memory, a native method, right? So this get runtime is a static method, but it's not native. So this returns a Java object, and this free memory is actually a native method. But it doesn't really matter for us. So in test 3, so I'm just going to select this Java object and create, run the Java Edge to update this header file with this new method, and then go back to my C++ code. And in the C++ code, I am going to have a pointer to JVM, and J class is the calling class. Okay, and what do we want to do here is we want to, from runtime class, we want to call a method which is get runtime. Okay, and this get runtime is a static method, and then after that call this returns a J object, and then call free memory on that object. All right, so we need to get the meta information about this runtime class. So J class, basically runtime class is environment or JVM find class. Okay, and then what is the signature of this runtime? This is inside Java lang runtime, right? So we go here and say java/lang/runtime. This is the class path, and then we want to get a J method ID. Basically get runtime ID is JVM get a static method ID, and we pass the J class reference runtime class. The name is get runtime, and the signature is it doesn't take anything, and then returns a runtime object. So the return type is L semicolon because it's an object. What is the signature of this object? Again, it's a runtime object. So java/lang/runtime. Okay, and we can double check it by actually going inside this runtime class and click on the get runtime. So where is this get runtime? And then go to Java perspective and look at the bytecode. And if I zoom in here, you see it doesn't take any parameters, and it returns L java/lang/runtime semicolon. All right. So again, it's good practice for you to try to write these manually, the signatures, but you can quickly go to the Java perspective bytecode view and then copy and paste the signature. So we get this J method ID, and now we have to call it, and it returns a J object. So runtime object is basically JVM call, and it's a object method, which means and it's a static, so call a static object method, which means we are calling a static method that returns an object. So the reference to the J class is runtime. Because this is a static, we are passing a J class as a reference. The method ID is basically get runtime ID, and then it doesn't take any parameters, so I leave the varargs alone, right? It's empty vararg. So, and then this J object basically is a runtime object, and then what I want to do, I want to call the free memory on this J object. So what I do basically, let's say JVM, because now I have a reference J object, I have a reference to the singleton object, that runtime object that this method returns. So I just and the free memory is not a static method, it's an instance method. Call JVM call basically, and this free memory doesn't return anything, right? The return type is actually it's a long, right? So call long method. which means it returns a long. It's an instance method that returns a long primitive. So we have to pass a J object reference. So I pass the runtime obj, and the method ID is, okay, so we need to get the method ID. J method ID free memory ID is JVM, and this free memory is not a static method, it's a normal method, right? So get method ID, and we pass the reference to the runtime class. The name is free memory, and the signature is it doesn't take anything, and it returns a long value. And if you recall, the signature of a long is a J, a capital J. So let's go back quickly to PowerPoint, and to refresh your memory, the signature of a long is a capital J. That's why I'm setting the signature to capital J. And again, if you doubt that, we can go to here, and we can go to this free memory and go to the bytecode view in Java perspective, zoom in. So it doesn't take any parameter, and it returns capital J, which is a long primitive. So go back to the C++, and here in the CPP file, and then so this and then it doesn't take any parameters, right? So J method ID is free memory ID. So we are calling two void methods, a methods that don't take any parameters. And then this returns a J long, right? J long is value, and J long directly maps to long on my machine. And then what we need now, so I just want to printf it slash decimal, and then I'm going to say value divided by 124 times 124. So let's say free memory is bytes. All right, so let's see if this compiles. So let's try to compile it, and then so it says that you are passing decimal, but the value is long. I think it's fine. So let's compile it again, and then let's copy the binary and then paste it to the Java project, and we go here, and let's call our native method, which is print memory, and let's see if this works. And it works, right? So this one, free memory equals 242 bytes, is basically is coming from the C++. 242 bytes comes from this Java. And this is a more complex example because we are calling a method. This is a singleton pattern. So we get we are calling a static method that returns an instance of the object itself, right? And then we call an instance method after calling this method again. That's why we have this call to the static object method, because it was a static method and it returns an object. And the object, we get a reference to this object, which is a type J object. And now we have to get this reference and call a method on this object. And the method is free memory. So we have to first get the method identifier of this basically free memory method, and then pass the reference to the J object that we just got by calling the Get Runtime method, which was a static method, and then print the result. So this was complicated, but if you understand this, you pretty much understand the whole concept of calling methods in C++. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.